Yo, what's up, guys? Okay, today gonna sorry. Uh, we keep going with the daily questions from Leetcode, and as usual, we will service as in an interview, real time, show thinking and coding. Okay, let's go. Today's problem is largest subarray with maximum bitwise n. Hmm. Reading the statement could give me the I mean, with the title, I could imagine the whole problem statement, but just read it for sure. You're given integers array nums of science. Consider a non-empty subarray from nums that has the maximum possible bitwise n. Subarray does mean continuous. Let k be the maximum value of the bitwise n of any subarray of nums. Then only subarrays with a bitwise n equal to k should be considered. What does that mean? Okay, okay, understand it. Turn the length of the largest subarray. Oh, that's it. Just like total, just like the title, it already said about this statement. Uh, okay, in the overall, we just need to find a subarray in this nums, so that the length of this is largest. But the first condition we need to consider about is the the the, the bitwise n of that subarray is the maximum one. Okay, let's check the a look at the constraints. That is 10 power 5, 10 million. Okay, numbers is 10 power 6, 100 million. Oh, is that true? Actually, hit 1 million, and at 10 power 5 is just 100,000. Okay, it's good. All right. Let's think about this problem. Bitwise ends. First of all, we need to understand that bitwise end is something like this, and you end something 0, 0. You end with 0, you got 0, but 2, 1 and together get 1. That's the only way to get 1 is from 2, 1. So a subarray from, for example, you got a subarray this, I don't know the value, but uh, the bit one, a bit, for example, let's use some this this. Okay, for example, you got this one, and separate you got the first bit on is set if that separate always contain on the number that start that the first bit is already one. For example, this you got one and the end only one. But actually you extend it to this, the first bit of on the element is not one anymore. We got 1 0 here. So to maximize from a I position, to maximize to find the trace that the I and J, the array from I to J is the maximum store. We need to identify the next position that's a 0. Why? Because that's person minus 1 a e on 1. For example, this the first bit. First on, we need to know that the bitwise operators is something that's not that's bit. Each bit is independent. That means we can process each bit. And to maximize, we can consider from the left to right because the left side is the highest bit. Sorry, highest bit. That means if it is set, it's always large, right? And it's not affect the next. If you got this, it must be large. It must be larger than this. Sure. Even this is always larger. Okay. Okay. From this, I will find the next 0. That's this. Okay. And minus 1, I call it minus 1. We got 3. So h. I mean this is j plus 1. And minus 1 we got j. And on from I to j is the on 1. That's it. So from I to j, we will maximize this 1 as 1. Okay. and we got two remaining bits. Okay, for example, we got an array of on 3-bit integer for simpler demonstration. Uh, okay, the next one, the zero here, actually it's zero, so we don't need to consider it anymore. It's always zero, and this is zero too. And how about this? How about this one? You find the next, actually this, and the first bit is zero. The one here you find the next zero, but actually it here is on the array from this to this, it contain it, the bit, the second bit is always, second bit is always one, so it's one, and the tray here, sure, and sorry, the tray here, and next bit, let's see, one two, the one, and we need to find the first zero, that's this, and that's mean we just ignore this and go to this, and because from I to j is only one, so the n is 1 2, and we got the maximum one is 1 0 0, that's when you store these two bits. You got I mean 0 1 1, that's maximum way. Okay, this problem turns out we need to find from an I position, we find the next j position, that's the j is as far as possible, and the store of it, the n of it is maximum as possible by iterating each bit from left to right, and find the trace that are from I to j, that bit is always one, and you can see the trace is always go down. It's always go down because but that means we're gonna got the mass of tray on tray here, you know, because for the first example you got change the color. The first one here you find the tray is no, sorry, actually the tray is actually this, and for this the tray is actually this, and actually we um all right, so the first bit, if a bit is zero, we just ignore it. Sorry, wait a minute. First bit here. If it is already one, oh, so the answer is the mean. Actually, the first one is one is obviously large than you get the next store with this. This is much larger than this. I just want to say that the AND operators, it only reduce the value, the 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 value. Okay. I'm sorry, then my recording is always have some problem. Okay, you see, you see it? I hate my this recording. OBS, so stupid. Mm, but I don't know what another apps to use. All right, you understand what I mean now? Just start coding. Just find the next J that's e so that from I to j is on way one. To resolve it, identify the nearest zero and minus one. The position of the nearest zero minus one is the so it makes sure that from I to j to that position minus one is on with one. Just demonstrate again to make sure you, because my recording is just off for some reason. I don't know why. I will demonstrate again. This one, the first bit alpha next zero is this, so you can ignore this and go to this, and you will got the first bit E on. And actually, the first bit E on is always the best because it's independent. It's always larger than this. It's always larger than this. So if from left to right we can turn on any bit, just set it. Just try to make it one. Understand? Okay, so after the tray here, we stop it. Actually, the tray here, but the second bit to maximize, you could go to here because on the bit is 0 1 1 1 1, so it's maybe one, but actually a tray we to maximize we but keep the tray here. That's mean the mean of on tray. All right, now just code it. We need to store the bits, the last 0 bits by I'm gonna create a vectors like last 0 of actually 10 power 6 is we got about 20 bits of, okay, it's on the ball. Just say side the last position from -1 to 0 while the last 0 4 bit is bit from sorry this I from the highest to the 20. Yeah, first of all we need to find the highest is actually this is the 0 1 2 and this is the highest, so I gonna fall from try try to find the first bit if we can, the value here. The J is the last 0 of this bit and it's -1 for sure, -1. And actually if this bit if J we need to update first. Okay, we could do it right in this loop. Last 0 of this bit if here nums I, siglen p and 1. If you watch my previous video, you will understand this Bismuth manipulation operator. Actually is a not, that means it's zeros. I'm gonna stay 0 of this bit is I. Sure, get this bit and you know if trace the mean I less than 3, so the bit is 0, and if I is less or equal to 3, this must be 1. Okay, the value turn out this bit is just turn on it, and the next okay, this is the you know the tree, I mean tree for sure is like I gonna assign this maybe f trace is actually is less than if it's larger, so is oh wait a minute, just let me think. Trace always lower down, but for example this tray is here, all right, it's the maximum one. You want to maximize this, you always want it, that's so easy, but this the check is 0 here. The 0 is here, so just it's 0, so from we just need to get to this position. We not want to exit the tray, the previous tray include there, but the egg case the zeros is actually this position, so we could turn it to any position. The 0, okay, let me fit if I actually if I less than j is less I, that means exactly this position, so we could extend the 0 to anything. But actually if I is less than j, that means the mean j is the mean j tray because we could to keep it maximized. We can't stand it anymore. We just skip it and keep it smaller and smaller. In that case, we don't need to reduce the mean tray because yeah um, actually we could if that bit is 0 and that bit itself is 0, so we could attach to any position for sure. And gotta turn the bits on. Step 3. Supplementary doesn't mean anything. Just let me think a little bit. Trade doesn't mean anything. Sure. Something. Got this line. 0. This is actually 1, 0. This is 1, so we could attend to this for sure. And the next position, sorry, I'm gonna, what is 1 and this is 0. I'm gonna stand to this. Okay, it's okay. And there is 0, so never mind, it's just always 0, so we can attend to this anyway, but the meaning here. And one thing you can extend to, maybe I gonna use this 0. You just can extend to this, and it's like it's smaller, so okay, it's okay. And one you can extend to this, but actually you just can't stand to this. Also, it doesn't matter. The main trait here is like this doesn't matter. God, it doesn't matter. Okay, it doesn't matter. Why? I need to store the mean. Just get the mask. What does this? What does this? Okay, now we got maximum value. I just want to print it out for sure. Yeah, it's always yeah. Otherwise, what the bit 1, 1. This is and upon the find you got to find because what Yes, I know. Yes, and I minus one is always that. Oh, y is 5. 0, I, signal P is 1. Actually, it's now. So the first bit for sure. And the 0 here, here. So we turn on this and we got to 1. Why just honest mistake? Honest silly mistake I made today is so stupid. Alright, good. Good. If values is large than mass value, we store mass values in value and mass length here is actually is the oh my god, what that? Oh, that's why we need to store the mean value. Oh my god. Got it. But look like it's too slow. Check out the first one. Oh my god, just overthinking. God, we find a maximum one and the continuous equal value is exactly the mass and god, I overkilled it. Oh, a sad day.